This is Bob Capetta from the University of Illinois at Chicago, and this is Math 121 Pre-Calculus. Final Exam Review, Part 2, Problems 11 through 13. We want to plot these polar points. We have P, which is negative 5 pi, Q, which is 3 negative pi over 3, and R, which is negative 4 pi over 4. So if we're looking at negative 5 pi, here's pi. But negative 5 requires us to go the other direction. So we have to count off 5, 1, 2, 3, 4, 5 in that direction. And there's P. QR is 3, and the angle theta is negative pi over 3. So negative pi over 3 puts me here. 3, 1, 2, 3 will land in that spot. There is Q. And then negative 4 pi over 4. So we go to pi over 4. 45 degrees. We're going out negative 4. So if that's the case, 1, 2, 3, 4 back the other direction. So there is on pi over 4, continuing back the negative direction, 4 spots to give me negative 4 pi over 4. Now we want to express each of these in rectangular form. So, what is our relationship here? This is our rectangular form: over for x, up for y. Our polar form, r distance from the origin, theta the angle with the x-axis. So how do we convert these things? We're given r and theta. Well, we see cosine of theta is adjacent over hypotenuse, so cosine of theta is x over r. So r cos theta is x. Sine of theta then is y over r, opposite over hypotenuse. So r sine theta is y. So I have r and I have theta. To convert them to x and y, these are the formulas I'm going to need to use. So if I have P is negative 5 pi, so that means R is negative 5 and theta is pi. So X is R cos theta, that we have up here, R negative 5 cos pi. So negative 5 times negative 1, X is 5. Y is R sine theta, so that would be negative 5 times the sine of pi. Sine of pi is, of course, 0, so we get x is 5 and y is 0. Going back to the polar graph, x is 5, y is 0, x is 5, 1, 2, 3, 4, 5, x is 5, y is 0, laying right on the x-axis. So we can even see that. So indeed, this p of negative 5 pi in polar form is the same as x is 5, y is 0. Next we have q. Tells us r is 3 and theta is negative pi over 3, and we still use these same conversions. So x will be r, 3 cos theta, cos negative pi over 3. Cos negative pi over 3 is the same as cos pi over 3, which is a half. So we get 3 times a half, x is 3 halves. Y is r times the sine of theta, r 3 times the sine of negative pi over 3. The sine of negative pi over 3 is the negative of the sine of pi over 3. So that's negative root 3 over 2. 3 times negative root 3 over 2 is negative 3 root 3 over 2. And you'll recognize that x is positive and y is negative. That puts us in the fourth quadrant for q. So you can see x is positive, y is negative for q. So at least that much we can verify by looking at the graph. And there's one more of these. R is negative 4 pi over 4. So little r is negative 4. Theta is pi over 4. X is r cos theta. So negative 4 cos pi over 4. Negative 4 times root 2 over 2. Negative 2 root 2. Y is r sine theta, so negative 4 sine pi over 4, which is also negative 4 root 2 over 2, negative 2 root 2. So x and y are both negative, so that should be in the third quadrant. Let's take a look at the picture to see if that's the case. And you can see, indeed, when we graph r, both x and y are negative. We are in the third quadrant. Next, we want to look at these 3 points given in rectangular form, P, Q, and S. We want to plot them and then convert them to polar form. Well, this first one, x is 3, y is negative 3 root 3. Root 3 is about 1.7. So negative 3 times 1.7 is a little bit more than 5. So if we're going to go over 3 and down a little bit more than 5, 1, 2, 3, 4, 5, just a little bit more than 5, you can see that we're going to get our p right about there. 1, 2, 3, 4, a little bit more than 5. P is 3. Negative root 3. Q is negative 6, 0. X is negative 6, 1, 2, 3, 4, 5, 6. So we get Q is there, and then S is 4, negative 4 over 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. We get S is pretty close to P. Notice both of those are in quadrant 4. We want to convert each of these points to polar form. So how is that going to work? Well, we have this triangle over x up y, distance from the origin r, angle from the x-axis is theta. So looking at this, we can see x squared plus y squared is r squared, and the tangent of theta is opposite over adjacent is y over x. So if we have negative 3 root 3, how is this going to work for us? Well, first off, on x and y, x squared plus y squared is r squared. 3 squared plus negative 3 root 3 squared is r squared. That's 9. 3 squared is 9, root 3 squared is 3, 9 times 3 is 27, so we get 9 plus 27 is r squared. 36 is r squared, 6 is r. That's our distance from the origin. Now again, P is over 3 down 3 root 3. So we get this sort of a situation. And the distance from the origin is 6. I want to find this angle alpha first. Remember, theta is measured from the x-axis going in the counterclockwise direction. So looking at alpha, if we're going to use tangent of alpha is opposite over adjacent. 3 root 3 over 3. It's just going to be root 3, ignoring the sign for now. So if the tangent of alpha is root 3, that means that alpha is pi over 3, or 60 degrees. But then all the way around to get theta, from the positive x-axis over here, theta will be 2 pi minus pi over 3, or 5 pi over 3. So for P, we have the r value of 6, and we have theta is 5 pi over 3. That is the polar representation of that point P. Next up, we have negative 6, 0. Well, let's just go ahead and use this formula, although it may be obvious what r is. X squared plus y squared is r squared. Negative 6 squared plus 0 squared is r squared. 36 is r squared. R is 6. Now, negative 6, 0, where is that? Well, we can see it. It's right here. So the angle, I would argue, is obvious. If you're on the x-axis going back 6, the angle from here to here is going to be 180 degrees. So the theta we're using there is pi. So our polar form is r is 6 and theta is pi. We can call q 6 comma pi. We're able to visualize that angle quite easily. And we have one more. We have s is 4, negative 4. Again, let's go ahead and find r. X squared plus y squared is r squared. 4 squared plus negative 4 squared is r squared. 16 plus 16 is r squared. 32 is r squared. So r is root 32. But 32 is 16 times 2. Root 16 times root 2, r is 4 root 2. So over 4 down 4, we want to find the angle. And again, I'm going to find this angle alpha, but recognize that theta is measured from the positive x-axis. Theta is opposite over adjacent, tangent is opposite over adjacent. Tangent of alpha will be this length is 4. Tangent of alpha is 4 divided by 4. Tangent of alpha is 1. So alpha is 45 degrees, or pi over 4. So to get all the way around to get theta, that would be 2 pi minus pi over 4, which of course is 7 pi over 4. So for this point S, r is 4 root 2 and theta is 7 pi over 4. That's the polar representation for that point S. Here's some information that we have. Right, x squared plus y squared is r squared. Tangent of theta is y over x. Cos theta is x over r, so r cos theta is x. Sine theta is y over r, so r sine theta is y. We want to convert some equations to rectangular form. So I'm going to start with r equals 10 times the cosecant of theta. I want to eliminate r and theta and rewrite in terms of x and y. Now, this is the information I have. First thing I'm going to do is rewrite it as r equals 10 times 1 over sine theta. Now, multiplying both sides by sine theta, we'll have r sine theta on the left, right? It'll be 10 times 1 over sine theta times sine theta, just 10. So we get r sine theta is 10. But what is r sine theta? R sine theta is y, so this becomes y equals 10. The next one we want to convert to rectangular is 6 over sine theta plus 2 over cos theta equals 8 over r. Let's multiply both sides by r. If I do that, the left-hand side becomes 6r sine theta plus 2r cos theta equals 8. But what is r sine theta? That's y. So this piece is 6y. R cos theta is x. That piece is 2x. So we get 6y plus 2x equals 8. Next we have theta is pi over 6. Now here's our hint. Tangent of theta is y over x. So let's take the tangent of both sides of this equation. So the tangent of theta is the tangent of pi over 6. Now, the sine of pi over 6 is a half. Cos of pi over 6 is root 3 over 2. So the tangent of pi over 6 is 1 over root 3. So we get tangent of theta is 1 over root 3. But what is tangent theta? Tangent theta is y over x. So we rewrite this as y over x equals 1 over root 3, which is fine, perfectly acceptable answer. If you want to write y as a function of x, multiply both sides by x, and we get y equals 1 over root 3 times x. Line through the origin with a slope of 1 over the square root of 3. How about r equals 6 sine theta? Can we convert that to rectangular? Well, we've got to look at what we're given up here. I know r squared is x squared plus y squared, and I know r sine theta is y, and that's going to be our strategy. We're going to multiply both sides of this by r. So we get r squared equals 6r sine theta. What is r squared? R squared is x squared plus y squared. What is 6r sine theta? That's just 6y. So that the equation becomes x squared plus y squared equals 6y. And that will conclude this lesson.